here is the syllabus. The first slide about syllabus. So first of all, this class is required if your major is mechanical engineering. So that is the required course. Required course means that if you failed for this is the course, you will not get your degree. Okay? You understand, everyone? So it's very, very important. Make sure you get a high grade for this class. The lecture and this as of today, and we are going to have in-person lecture every Monday, Wednesday, Friday at this room, 2:10 to 3 o'clock p.m. I'm sorry, not a.m. We will also have office hour and virtual meeting via Zoom to minimize the spread of COVID-19. And we have office hour. So I talk about this office hour with our other classes. This that 4 to 5 Monday, Wednesday, Friday, and work best for them. So what about your opinion? So 4 to 5 p.m. Monday, Wednesday, Friday work for you? So if it work for you, raise your hands, please.
Sorry, could you repeat your question?
4 to 5 Monday, Wednesday, Friday for office hour. Okay, so most students, 4 to 5 p.m. Monday, Wednesday, Friday works for most students. For other students, if you cannot make it for the 4 to 5, and we can have individual meeting. What does that sound? All right, great. So this is write down, draw down this change 4 to 5 p.m. Monday, Wednesday, Friday for office hour. I will be there all the time. Okay, so if you have any questions, and you feel free to stop to the Zoom meeting. I prefer to have Zoom meeting, right? So we still not, and we still have some cases here. So Zoom meeting. So manufacturing processes. This is textbook for engineering materials. Cavalcandia. So this guy wrote the several versions. You can use either the 5th edition or 6th edition. It is not. They do not differ too much. The latest one is 2017. So it's highly recommended that you have one copy. However, if you don't want to buy, that's okay. And we have all these slides. All these slides will be enough. So Canvas, we will use Canvas a lot, and all these materials will be posted on the Canvas. Right. So I will make announcements on Canvas as well, so you can see my announcements regarding the homework and exams and everything. The course prerequisites, and supposedly you should have taken this as IC 201 and short practice. If you have not taken this one, but still you can sit here, that means and you have already got this is the exemption, right? So that's okay. So if you have not taken this one, and I would suggest that you spend more time to understand all these concepts. Questions regarding this slide? No question? So one takeaway is that the office hour changed from 4 to 5 p.m. Monday, Wednesday, Friday. So this is from this slide. So course information, and what is this course about? This course talks about and provides the detailed discussion on various manufacturing processes, for example, metal casting, metal forming, metal removal processes, so e.g. metal carding, abrasive, chemical, electrical, and high energy beam. So this one, if you have taken engineering shop course, machine shop course, you will know what is the material removal processes, right? So other manufacturing processes, and students learn the fundamental principle of manufacturing processes by working hands-on with machine tools. And for this case, we will do a lot of this is the simulations, modeling and simulation. Okay, so the current manufacturing techniques, and for example, rapid prototyping, manufacturing cells, and lean manufacturing are discussed. And I'm going to show you how to use the CNC, the advanced one. The modeling and simulation of manufacturing processes and using IBM are explored. I already the purchase, in the process of purchasing, we have in the purchasing process of this software. So we will do several 5 or 6. This is the lab projects using the FEM software. So this is what this course is about. So course objectives, after you finish this course, and you are supposed to be able to do the following things. First, you will understand the various manufacturing processes, and you should be able to operate manufacturing machines. But for this class, we will not operate the machines. However, I'm going to introduce you the CNC machine. Right? So know how to model and simulate manufacturing processes using FEM. So this is very, very important. And we will spend a lot of time for the modeling and simulation of manufacturing processes. Communicate verbally, graphically, and in written. So you have several reports, level project reports. So any questions regarding this slide? No question? Okay, next slide, the tentative topics and what we are going to learn. So overview, we are going to learn overview of manufacturing processes. And we know that if we want to manufacture something, we must know some information about get some knowledge about engineering materials and material properties, right? Materials, you have workpiece, then you manufacture to get your final products. We will learn surfaces, typology, and other considerations in materials processing. And then, so this is fundamentals. Then we learn, and this is the detailed, different various manufacturing processes. Metal casting, this is metal casting, and we can build something from the raw material. Molding of plastics is for plastics also. So actually, these two guys together because they are very, very similar in principle. Okay. Then the bulk deformation process is deformation. Is metal forming actually rolling, forging, and extrusion. So for these 3 guys, we will not use there's no shapes here. So we basically the deformation. Then sheet metal forming. And so this bulk forming is a sheet metal forming, very thin the plates. Or this is a sheet. So then metal removal processes. This is the most important part because this is most commonly used manufacturing processes. Metal cutting or called machining, the same thing. Metal cutting and machining. I'm a machining guy, right? So metal removal process, this is traditional. So this is non-traditional. Non-traditional metal removal processes include abrasive, chemical, electrical, and high energy beam, and use these kind of means and to remove the unwanted material from the raw material. So this is traditional, non-traditional. Then we talk about powder metallurgy and processing of ceramics and glasses. So this is powder metallurgy. Right? So then after that, so this is ceramics and glasses, and then we talk about polymer and how to process the polymer. Polymer processing and additive manufacturing. Additive manufacturing is a very, very hot research area. So we are going to talk about this additive manufacturing. I will give you a lot of handouts for additive manufacturing. And also micro and nano manufacturing. So this is the non-traditional advanced, this is advanced manufacturing also. And then talk about laser-based machining. So basically this additive manufacturing, micro and nano manufacturing, along with laser-based machining, and they are related to my research. I'm going to show you the latest the research results I have already got. Also, that research results that are available in the literature. Okay, so I want to teach you the traditional things well as established things. At the same time, I'm also going to introduce the newest things to you guys. So then we talk about machine tools and their operation, lathe, milling, drilling, and grinding. So this is machining things, CNC. CNC stands for computer numerically controlled machine. So there is mechatronic system. Right? So mechatronic system, we use this mechatronic system and to control the machining of the workpiece. And finally, we use FEM modeling and simulation of various metal forming processes and manufacturing processes. So this is our tentative topics. Basically, pretty much, we are going to cover everything I just listed here. Any questions regarding these tentative topics? No question? Okay, you have a basic idea about what will be covered. So assessment methods. When I was a student now, I'm also very interested in this part, right? Assessment, finally, and what kind of grade I'm expecting. So assessment methods, we will have take-home midterm, and the tentative date is March 9th. Tentative, that means it's not the, I might change it based on the situation, right? So tentative take-home, and take-home final also, May 11th. And we will have take-home final. I will give you 24 hours, maybe 48 hours. And at that time, I'm going to talk with you and to see how many hours you need to finish everything. But for this is take-home midterms and take-home final exams, I need to tell you, before you do anything on this, and you need to sign a honor pledge sheet, right? So that's honor pledge sheet states that during this period of finishing this exam, and you are not allowed to communicate with anybody else by any means, right? You understand, guys? So I want take home, I give you more time to finish, but by yourself. So this is very important. And then we will have weekly homework given on Friday and due on upcoming Friday. So this is weekly homework and kind of calculations. On 11 projects mainly about this is the FEM modeling, right? FEM modeling, and at the very beginning, I'm going to teach you how to use abacus and to do the metal forming and these kind of things. Then we use advanced edge FEM and to model the material removal processes, machining processes. So this is a level project. So all homework assignments and take-home exams will be sent out to students in PDF. I will send this as a PDF. I will not give you hard copy, but today I'm going to give you hard copy. The reason is that the syllabus is very important, right? But for the homework, I'm going to send out the emails to reduce the probability of touching this hands-on the hard copy. You guys agree? Okay. And we'll be collecting in PDF emails. After you finish, you just send the PDF file to me, and then I will grade. Right? So this is assessment. Evaluation. The homework assignment will be 30%. So that means, and you need to treat this homework very seriously. If you suppose you do everything else perfectly, but homework, you just lose all the points. That is extreme case. I just give you extreme case. That means you can only get 70%. Right? 70% is around. 70% is what score? 70% is stipends. Am I right? So my point is that pay attention to the homework. Be serious about the homework. Also, if you are not serious about the homework, I don't think you can do the midterm and final very well. Right? So pay attention to the homework. If you do everything very well, definitely you will get a grade. No problem. Questions? So here is a final letter grade. 90%, I think you are very familiar with this grading scale. 90% or above will be A. However, if you get a 92.5, I will give you A also. That's no problem. Questions? Question regarding this is assessment measures and this final grade. Also, I want to tell you, I will have the redo policy, and if you are not familiar with me, and I'm going to talk about this redo policy in detail. Redo policy means that for the midterm and term, this final, for the first time, if you, for example, so for the one exam, this exam can be final exam, can be midterm. So suppose if we have 100 points and for this in total, right? So however, and for some reasons, and you did not perform well, you only get 60 points, right? That means, and you lost 40 points, right? So if this is the case, I'm going to give you redo this opportunity. So if you work on this is on problems that you have lost the points on, okay, guys. Suppose you have finished all these, redo all these 40 points, all the problems that you have lost the points on 40 points, and then you will get 50% back. Understand, guys? So that means 40, 50, that means you will get 20 points back. So 60 plus 20, you will be equal to 80%, 80 points, right? These 80 points will be counted as the score for this exam. Question?
So you're saying after you grade it, like, do we take it back home and work on it ourselves on those problems that we got off?
Yes. You understand? So this is one case. Another case is that we still have 100, but at the very beginning, for the first time, you get 90%, 90 points, 98 points, right? Okay, so you work on these 2 points, and these 2 points multiplied by 25, and you put them together, finally you get 99 points. Understand? So this is applicable for both the midterm and the final. So because I have learned that if we learn from failure, okay? At the first time we made a mistake, if we can correct this mistake and we can deepen our understanding, and it's very, very good learning strategy. However, this is optional, and if you have an option not to do it. Question? I want my students to have a high GPA. Question? Okay, no question, and we are going to talk about several important notes. And since this is the syllabus has a contractual attributes here. So as of today, and we are going to have traditional face-to-face lecturing this semester. That means, however, if we receive the mandate from our university, say everything move to online, so we will do it. But as of now, we will have face-to-face lecturing this semester. So lecture attendance is highly recommended. However, if you cannot make it to attend the class in person, because the Zoom meeting is open, right? So you can still stay in your apartment or the dorm and to watch the video, to live, to have this is the Zoom meeting on live. Also, if you cannot watch this, have this live Zoom meeting, but after class you can still watch the video. I'm going to post this recordings online. Okay? So, however, for the courtesy, if you cannot make it for either in-person attendance or virtually, and I would suggest you send me an email. Okay, send me an email telling me that I cannot do it for any reasons. I'm totally fine with all the reasons. But for the courtesy, notification should be provided at least 1 hour before class, if possible. All lecture will be recorded and posted online. So you can watch this video multiple times if there's a need. The students need to complete all the exams. We don't have quiz here. Okay? We don't have quiz. We only have midterm and the final. The home assignments and the final projects. We don't have final project. We have level projects. I'm talking about level projects as their final grade. So no makeup exams, quizzes, homework will be given unless you get my prior permission. Okay? If you cannot make it, you need to let me know and get the permission, prior permission first. And so students will be able to make up at least a maximum of 2 missed assignments and through completion of alternative exams quizzes homework. So alternative means that I will not give you exactly the same quiz homework. This is the exams. I will have another version which is on the same level of complexity and technical difficulty. Okay, and within 48 hours of the originally scheduled exam, quiz, and homework due time. Any question regarding this slide? No question? So if the professor becomes ill and is unable to continue teaching, another guy will teach this course. We have teaching will result in automatic grade of F for the course, especially for the homework and also for the level projects. Because level projects, we will do a lot of level projects on the modeling and simulation, and you cannot copy and paste the models from other students. Right, guys? That says copying models is kind of cheating. It's very bad. And I want you to get your model by yourself. Right? So cooperative learning is highly encouraged. You can communicate with your peer students and with me and with anybody else for learning. However, for example, they're sharing ideas on homework or project, but you must understand the material and turn in your own work. I need to tell you in advance, I will not accept collective work, right? I only accept individual work. Individual work means that I have 26 students. I'm supposed to get 26 individual homework assignments for all of these homework. Understand? Collective homework or the exams is not allowed. Copying homework computer codes from another students considered cheating, and you will most likely not perform well in this course unless you do understand the homework. Questions regarding this slide? No question? Yeah, sure. So if there is no question, so this is the last slide about this our syllabus. If there is no question, that means you are okay with this syllabus, right? Okay, the online students, are you okay with this is the syllabus? Huh? Online students. Okay. Eric and Shane, are you okay with this syllabus?
Yeah.
Okay, thanks. Okay, then we talk about the introduction to the manufacturing processes. So manufacturing processes, manufacturing is a process of converting the raw materials into products. So this is, we know this one, right? So we know we have some idea. And it encompasses the design and manufacturing of foods using various production methods and techniques. So this is the manufacturing, how we define manufacturing. So look at this table. This is a table, the raw material, we can get this raw material, and then we machine it to get this is the surface, and there is two legs. So we build the two legs, then we assemble them together to get the final product. This is gas. Right? So raw material. The manufacturing began about 5,000 to 4,000 BC, and with production of various articles of wood, ceramics, and stone, and metal. So we also know that the human history is divided into several ages, right? The Stone Age, New Stone Age, Stone Age, right? Stone Age means that when people use the stone as a material for the tools, right? Stone Age, wood, ceramic, stone, and metal. So manufacturing adds value defined as monetary worth onto the items. So raw material is very, very precious, but you cannot use it directly. You need to build it, convert this raw material into a final product that you are looking for. So that means manufacturing ends is the value. Right? So manufacturing activities must be responsive to several demands and trends. So, what kind of demands and trends? And I'm going to talk about it here. So I copied this one from the PDF of the textbook. So the product must fully meet design requirements and specifications and standards. So this is the design requirement. It must be manufactured by the most economical and environmental friendly method. Right, so as I said, raw material cannot be used directly. So we have raw material, we have some idea on what kind of design requirements and our final product must meet. And specification standards, then we can get this raw material and then we manufacture it. Right? Manufacture it must be economical and environmentally friendly. So otherwise, you will use a lot of money, a lot of time, effort, and to produce the final product. Quality must be built into the product at each stage from design to assembly, rather than relying on quality testing of the product is made. So for each of stage, you need to have quality control. Highly competitive and global environment, production methods must be sufficiently flexible and to respond to changing market demands, types of products, production rates and quantities, and on-time delivery to the customer. So this, because the competition is very, very fierce now, so this one is very, very important. New development in material, we have new materials, production methods, new manufacturing methods, and computer integration of both technological and managerial activities in manufacturing organization must constantly be evaluated with a view to their timely and economic implementation. So raw material, manufacturing methods, and also the managerial activities. So manufacturing activities must be viewed as a large system, each part of which is interrelated. Right? So such system can be modeled in order to study the effect of various factors that change in market demands, to what kind of products are being needed, and product design, materials, cost, production methods, and product quality and cost. So a manufacturer must work with the customer to get timely feedback for continuous production improvement. A manufacturing organization must constantly strive for high productivity, defined as the optimal use of all resources, materials, machines, energy, all these factors. Okay, so you need to consider all these things. So I just give you a sketch idea. Any questions regarding this slide? So here is a history of the manufacturing. So manufacturing, this is from this before 4000 BC and until 1600 to 1700. So there are different materials, metals, and casting, various materials and composites, forming and shaping. This is manufacturing methods. These manufacturing methods also. So you can see different age at different ages, and people use the different materials. And you need to have different manufacturing processes, manufacturing methods, right? So this is understandable. So you can just take a look at this one. It says this slide is too informative. It contains a lot of information, and you can take a close look at this. So this is continued from 1700 to 1800 until this is the recent time, the contemporary time. You can see the different materials have different needs different. This is the manufacturing processes. So this is more recent activities here. The carbon nanotubes, graphene. This is the materials here. There are two information. I will not go through this slide, right? So, and you can take a look if you have time. So then we talk about the development. This is the processes. So whenever you design something and manufacture something, so here is so we have two pictures here. So this first one shows various steps involved in designing and manufacturing a product. A second one, I'm showing general product flow from market analysis to selecting the product and depicting concurrent engineering. So this is concurrent. See, always from one step to the second one, to the next one, there is two arrows. Two arrows means that you need to have iterations. So this you need to the concurrent. This is concurrent from here to market and specification, conceptual design, and detailed design, manufacture, sell. So this is more this is general product flow. For here, so definition of product needs, marketing information, conceptual design, evaluation, and so on and so forth. Here is the computer-aided design. Okay, so computers are commonly used the tool for designing. So this is computer-aided manufacturing. So computer integrated manufacturing (CIM), and also the packaging, marketing, and this is sales and the literature, and then go to product. So this is we have two figures here. Okay. Change one question. Actually, I already answered James' question. Then we talk about this the shapes and some common methods of production. That's the shape of features. Okay, a flat surface, and we usually have rolling, planing, brushing, milling, shaping, grading, and parts with cavities. We have cavities here, and we use annealing and EDM, electrical discharge machining, electrochemical machining, ultrasonic machining, blanking, casting, all those things. And parts with sharp features, we have sharp features, permanent mold casting, machining, grinding, fabricating. Thin hollow shapes. Thin hollow shapes is very, very difficult to machine. So you need to be very, very careful. And slash casting, electroforming, and filament welding. You can take a look. Okay, tabular shapes and the tubular parts, the curvature on thin sheets, are opening in thin sheets. This is cross sections. For all these things, based on different shapes or features, and you can use this table and to look for the desired, the highly appropriate these manufacturing processes. Okay, so based on different features, you need to select different manufacturing processes. So square edge, small holes, a lot of other things. You can just take a look. I will not read all these things. So by the way, guys, so this manufacturing processes class is very, very conceptual. Yes, I want to know this information, and if there's a need, and you just look at the textbook to get the answers. The selecting material, you need to select material, right? So this is all the commonly used material. Various material, metals, they are commonly used one, and carbon steels, alloy steels, stainless steels, and tool and die steels, the ferrous metal. And ferrous metal means that these metals contain the what? Huh? Yes, the iron. Okay, ferrous metals. Non-ferrous metals means that these metals do not contain the iron. So they have aluminum, magnesium, copper, nickel, and superalloy, beryllium, zirconium, and low magnesium alloys there. The plastics, thermoplastics, thermostats, and elastomer, and ceramics, and glass ceramics, glass, graphite, and diamond ceramics. Composite material actually, and they are the combination of these fundamental materials. Also nano materials, silver alloy, silver memory alloys, metal foams, amorphous alloys, and semiconductors. Semiconductors is very, very important for the computer industry. The skills in manufacturing. The skills. So here is the size of this angstrom, and 1 angstrom, the 10 angstrom equals 1 nanometer, right? 10 angstrom equals 1 nanometer. This is 1 nanometer to 10 meter. So this is classification. So this is nanotechnology, nano manufacturing, this is micro manufacturing, meso manufacturing, and this is the micro. This is the micron machining. So this is an example in nature, manufacturing processes, these examples. And so this is applications. So skills, what skills matter very important in terms of manufacturing processes and also the costs. And then we talk about computer integrated manufacturing. Computer numerical control is a method of controlling the movement of machine components by direction of coded instruction in the format of numerical data. We write a program, and this program will control the system. So adaptive control and also industrial robots. If you are mechanical engineering major, and when you for the first semester of senior year, and you will learn the industrial robots with me, right? So automated handling, automated and robotic assembly systems. So this is computer included. So, and we also talk about CAPP. CAPP means computer-aided process planning, right? And how if we have the raw material, if we have final the product, which is on the piece of paper, we have an idea of how it looks like, and then we need to have a computer-aided process planning. And to see this optimized process plans reduces planning costs and improve the consistency of product quality and reliability. Good technology. Good technology means that similar features of this is a material of this is a product, and they will be used. They will be machined using the same very similar manufacturing processes. And just-in-time production, and supplies are delivered just in time to be used for production. So parts are produced just in time to meet into assemblies, and products are finished just in time and to be delivered to the customer, just in time production. So cellular manufacturing, flexible expert system, also artificial intelligence. So this is a very hot research area. Machining of mold cavity is a give you an example. Cavity is very small. You can take a look. We have this micro milling. So this is the cellular manufacturing system. So you can see here is a cell, and this is the cellular manufacturing system. And so this cell and this cell, they are interrelated. Right? So general training manufacturing, new material, new processes, and we use computer modeling and simulation of manufacturing processes. Why this one is important? Because before you do the manufacturing physically, you need to do the modeling and simulation, and this one based on this, you can identify the potential problems, right? So you can reduce a lot of cost and time. So we are going to use this advanced edge FEM and to do this is FEM modeling of metal cutting.